shall now go through some standard formulas in derivability, that is the derivatives of some standard functions. Derivatives of some standard functions. Out of them, the very first one is everybody knows about it. Derivative of x square is 2x, derivative of x cube is 3x square, derivative of x power 5 is 5x power 4, derivative of x power 10 is 10x power 9, like that. Next one, derivative of x is 1 into x power 1 minus 0, that is 1. Derivative of x is 1, derivative of 2x is 2, derivative of 3x is 3, like that. Next one, d by dx of 1 by x. Moreover, we could have forgotten one particular style of representing a derivative. If you simply put a dash over that, it's nothing but the derivative of that, isn't it? 1 by x whole dash, 1 by x square whole dash, 1 by x cube whole dash, like that. What are the derivatives? What are the derivatives? 1 by x, what is the derivative? Minus 1 by x square. 1 by x square minus 2 by x cube. 1 by x cube minus 3 by x power 4. I think you are able to trace the style of getting it. And in general, what is the derivative of 1 by x power n? What is the derivative of 1 by x power n? It's nothing but minus n by x to the power of n plus 1. Minus 1 by x to the power of n plus 1 is minus n by x to the power of n plus 1. Now, let us have this as the formula. What is the derivative of 1 by x power n? Minus n by x power n plus 1. Come on, what is the derivative of 1 by x square minus 2 by x cube? The derivative of x power 4 minus 4 by x power 5. Like that we can have. Well done. Next one. Derivative of root x. What is the derivative of root x? What is the derivative of cube root of x? What is the derivative of fourth root of x? What is the derivative of nth root of x? If you are able to create a formula or create a result, it must be reused to any number of similar type of examples. For that purpose only, I like to ask you to tell me the derivative of nth root of x. What is nth root of x? Let us have a very simple piece of simplification at the side. What is nth root of x? Nothing but 1 by n into x power 1 by n minus 1. This is nothing but 1 by n into x power 1 by n by x power 1. It's nothing but nth root of x by nx, isn't it? So you keep this point in view. What is the derivative of nth root of x? What is the derivative of nth root of x? Nth root of x by nx. By noting it, derivative of root x by 2x, 2 root x, root x by 2 root x, 1 by root x by 2x, 1 by 2 root x, cube root of x by 3x, fourth root of x by 4x, fifth root of x by 5x, But you see, so many of us are very familiar with the answer that derivative of root x is 1 by 2 root x. Is it correct? How and why? It's very simple. It is evident. Square root of x means square root of x by 2x. Root x by x is root x. 2 into root x. 2 root 1 by 2 root x is correct. Therefore, instead of remembering derivative of root x is 1 by 2 root x, you try to remember that derivative of nth root of x is nth root of x by nx. Well done. Next one. Fourth formula. What is the derivative of 1 by nth root of x? Let us construct the same for the sake of ourselves. Yes, what is 1 by nth root of x? X power minus 1 by n. What is its derivative? Minus 1 by n into x power minus 1 by n minus 1. It's just nothing but minus 1 by n into x power 1 by n into x power 1. Isn't it? You can trace this as minus 1 by nx into nth root of x. So what is the derivative of 1 by nth root of x? This is nothing but 1 by minus 1 by nx into nth root of x. What is the derivative of 1 by root x? Minus 1 by 2x root x. What is the derivative of 1 by cube root of x? Minus 1 by 3x into cube root of x. What is the derivative of 1 by 4th root of x? Minus 1 by 4x into 4th root of x. What is the derivative of 1 by 5th root of x? Minus 1 by 5x into 5th root of x. Like that you can proceed. This is the way in which you are supposed to remember the formula. Yes. The next one is derivative of a power x is a power x into log a to the base g. Derivative of 2 power x is 2 power x into log 2 to the base g. Derivative of 3 power x is log 3 power x into log 3 to the base g. Like that. And it is not impossible to get this formula as by the usual way, limit as x. See, do you want to have the proof? It's very simple. Let me call this f of x. F dash x is therefore equal to limit as h tends to 0 a power x minus f of x minus f of a by limit as h tends to 0 a power x plus h minus a power x by h. By h, this is equal to limit as h tends to 0 a power x into a power h minus 1 by h. We all know that this is nothing but log e to the base g, and there is no h here to have the limit. Therefore, the coming answer is a power x into log e to the base g. It is purely believable. Yes, it is credible. Not only that, we could have traced so many formulae in the previous discussion. For all those formulae, there is only one formula, limit as x tends to, derivative of x power n is n into x power n minus 1. Even that can be proved directly. Limit as h tends to 0 f of x plus h minus f of x by h. Of course, so many of us call that formula as the fundamental or the first principle of differentiation, right? Using that so-called first principle of differentiation, we'll be able to have that derivative of a power x is a power x into log a to the base g. Derivative of 2 power x is 2 power x into log 2 to the base g. Derivative of 5 power x is 5 power x into log 5 to the base g. Well, derivative of e power x is e power x into log e to the base g. What is log e to the base g? 1. Therefore, isn't it? Right. In this sequence, let me write this formula also. d by dx of x power x is also there. That is d by dx of x power x. Let me write this formula. This can be proved, of course, by logarithmic differentiation. We shall later on discuss that in the next, that is the next session we'll be going to deal with that. So for the present, let us believe that the derivative of x power x is x power x into 1 plus log x. Derivative of x power x is x power x into 1 plus log x. Derivative of e power x is e power x. Derivative of 2 power x is 2 power x into log 2, like that. Well done. Next one. Now let us look at the derivatives of some trigonometric functions. Trigonometric functions. We all know that d by dx of sin x is cos x. D by dx of cos x is minus sin x. Derivative of tan x is secant square x. Derivative of cosecant x is minus cosecant x cot x. Derivative of secant x is secant x into tan x. Derivative of tan x is secant square x. And the proofs for this formula is beyond the scope of these sessions. Of course, they are very fundamental, they are elementary. Of course, every such proof can be viewed or observed in the pattern of first principles of a derivative. It's not impossible. Well done. Next one, derivative of sine inverse x is equal to 1 by root 1 minus x square. This can again be taken as minus cos inverse where all x belongs to minus 1 to 1. Good. Derivative of tan inverse x is one by 1 plus x square. The same can be minus for minus cot inverse x. Of course, it is for all x belongs to R because its domain is set of real numbers. And derivative of secant inverse x 1 by x root x square minus 1. This can again be taken as d by dx of minus cosecant inverse x for all mod x greater than 1. So to have the derivative like this, we should have mod x greater than 1 because there only secant inverse x's can be defined, isn't it? Yes. Next one. Now there are some fundamental formulae regarding algebra of derivatives. Derivative of f of x plus g of x is derivative of f of x plus derivative of g of x. Need not write in the notes, or it can be kept in mind. It's very simple and we use it for many number of times. Similarly, derivative of f of x minus g of x is derivative of f of x minus derivative of g of x. Derivative of a into f of x is a into derivative of f of x, like that. And the case of f of x into g of x or f of x by g of x, a separate discussion has been done. What is that? D by dx of u into v of x is derivative of first one plus derivative of second one. While forming the derivative of first one, second one will be followed just simply, and vice versa. What I mean to say is, this is v of x into d by dx of u of x plus u of x into d by dx of v of x. In very short form, uv whole dash. Whole dash means derivative of uv. u dash into v, v dash into u. Now you can extend this also, uvw whole dash. What can you say? U dash into vw, v dash uw, w dash u. Can you extend this to 3, 4 more functions, say u, v, w, t whole dash? We can, of course, but not necessary, because in our daily pattern of looking at the problems, we do not come across such functions. If at all there are something like that, we club 2 and 2 like that. 2 functions as one group, 2 functions as one group, we apply UV rule like that. This is what we call about product rule. Well done. Just like that, u by v whole dash. What is that? U by v whole dash. What is u by v whole dash? That is the derivative of u by v. U dash v, v dash u by v square. This is a combination of general rules regarding algebra of derivatives, regarding products and quotients. This is called a product rule. This is nothing but this. This is again extended product rule. This is a quotient rule by u by v, obeying the quotient of u and v, isn't it? Well, so it is called a quotient rule. This is a product rule. This is also a product rule. You see, there are some beautiful applications of this quotient rule. Yes, without applying this formula, you'll be able to have the answer directly for some particular models. What are they? Let us see. As we just discussed, there are beautiful applications of the formula u by v or quotient rule. What is that quotient rule? Let us again recall that. Of course, in the short form only we could have written u dash v minus v dash u by v square. It is there. What is d by dx of ax plus b by cx plus d? U dash for ax, a, for b, 0, v, cx plus d. V dash for cx, c, for d, 0, c plus 0, c. U, v square, a into cx, a into cx, they can be cancelled, leaving you ad minus bc. It is just nothing but the determinant AD minus BC by denominator whole square, that is Cx plus D whole square. What is d by dx of ax plus b by cx plus d? It is just nothing but AD minus BC by Cx plus D whole square. Well done. 2x plus 3 by 5x plus 10, rather 9. What is its derivative? AD minus BC, 18 minus 15, 3 by 5x plus 3 whole square. Again, x by 2x plus 3 whole dash. Come on. X means 1x. AD 3, BC 0 by 2x plus 3 whole square. Okay, right. 1 by 1 minus x, what is it? No. X by x minus 1. AD minus 1 minus 1 by x minus 1 whole square. Okay, right. Just like that is 4 by x plus 4. What is its derivative? Or x by x plus 4. What is its derivative? AD minus BC is 4 by x plus 4 whole square. Okay. So far, we have seen the application when and only when both numerator and denominator are of first degree. Now, let us observe this in another corner, that is through another angle. Let us see. If you have dy dx of a into f of x plus b by c into f of x plus d whole square. What can you see? You see, as usual, as in the previous case, a into d is ad minus bc by denominator whole square, that is cx whole square, into, for f of x, its derivative is f dash x. And it will be very, very clear if you can look at some numerical applications to that. We shall now do that. D by dx of 2x square plus 5 by 5x square minus 3. What is it? AD minus BC. Minus 6 minus 25 is minus 31 by 5x square minus 3 whole square into, in the place of f of x we are having x square, its derivative is 2x. Altogether it is minus 62x by one more application, 3 into e power x plus 4 by 5 into e power x plus 2 dash, that is its derivative. Here in this problem, in the place of f of x, what are we having? E power x, let it be ad minus bc, that is 6 minus 20. 6 minus 20 is minus 14. Minus 14 by 5 into e power x plus 2 whole square into, in the place of f of x, we are having e power x. Its derivative is e power x. So that the total answer is like that. We shall be making use of this formula. We shall be making use of this formula, isn't it? Good. Next. Now there are some special applications, application oriented problems are there. Let us look at such problems. F of x is equal to x minus x square plus x cube minus x power 4 plus x power 5 and so on infinity with mod x less than 1. Mod x less than 1. Then d by dx of f inverse of x. He is asking us. Therefore, to trace the answer for such questions, you may be attempting two applications. Number one, you must be able to know f inverse of x and then its derivative. First of all, you have to get f of x simplified. What is f of x? F of x is equal to a by 1 minus r, isn't it? A by 1 minus r. How? What is a by 1 minus r? What is a and what is r? It is very simple to look at f of x. It is just nothing but an infinite series, infinite geometric series whose common ratio is always less than 1. You see, the common ratio is minus x. Mod x is less than 1, isn't it? So mod minus x is also less than 1 because mod x is nothing but mod minus x. So we will be able to use the formula a by 1 minus r. A is x by 1 minus r is 1 minus of 1 plus x. The t is x by 1 plus x. Well, my dear, At this juncture, you must be knowing the style of getting f inverse of x directly. What is that style? Look here. If f of x is equal to ax plus b by cx plus d, then f inverse of x is, of course, this formula is valid. This structure, rather this style is valid when and only when the expressions involved in that are existing. Well, f inverse of x is equal to minus of dx minus b by cx minus a. X is not equal to minus c minus d by c, and x is not equal to a by c, of course. Okay, you recall that formula. According to that, what is its inverse? What is the inverse of x? F inverse of x is equal to minus 1 by, this is nothing but x plus 0 by x plus 1, isn't it? You apply that formula. Minus of dx minus b, that is x, by x minus 1. That is equal to 1 by 1 minus x. Minus x by x minus 1, or simply 1 by 1 minus x. This is f inverse of x. This is f inverse of x. Now you have its derivative. Of course, you can have the derivative by using the formula or by the direct finding the derivative also. 1 by 1 minus x derivative is minus 1 by 1 minus x whole square into minus 1 is just nothing but f inverse of x whole dash 1 by 1 minus x whole square. 1 by 1 minus x whole square. So this is the way in which we make an attack on these problems of such sort. Another formula is there. See, if at all there are only two functions, we use UV formula. If there are three functions, we apply UVW formula. Here there are 4 functions. What do you notice? It's very simple. F of x is equal to this is, I could have multiplied and divided with x minus 2. What is x minus 2 into x plus 2? X square minus 4. X square minus 4 into x square plus 4, x power 4 minus 16. X power 4 minus 16 into x power 4 plus 16, x power 8 minus 256. X power 8 minus 256 into x power 8 plus 256 is nothing but x power 16 minus 2 power, it is 256 into 256, 2 power 8 into 2 power 8, 2 power 16 by x minus 2. This is f of x. First of all, what is the question here? It's nothing but f dash x he requires. F dash x he requires. You apply the general u by v formula quotient rule. Come on. U dash 16x power 5 v dash 1 by v square. With the usual simplification, you will be arriving at the answer. It is not impossible. Of course, the main and crucial thing here that you have to catch is multiply with x minus 2 and x plus 2 in both numerator and denominator. That's all. Unless or otherwise it becomes a tedious fact to simplify them. Yes, of course. Next one. Another beautiful question is before us. You think of f of x is equal to integral part of mod sin x plus mod cos x for all x belongs to R. Here you see 4 functions are there. Sine function, cos function, modulus function, greatest integer function. Mod sin x plus mod cos x. It always lies between 1 and root 2. Everybody knows it. It always lies between 1 and minimum value is 1 for mod sin x plus mod cos x, and at most the maximum value is root 2. Therefore, as this lies between 1 and root 2, its integral part is always 1. That is, f of x is equal to 1 is a constant function irrespective of the nature of x. That you may have to catch here. That is the only thing in this function, in this problem, nothing else. There is nothing to do. The answer is obtained. What is the derivative of a constant function? It is 0. Why? Derivative means rate of change. Constant function means it never changes. Change is 0. So relative change or the rate change is also 0. Hence the derivative is 0. Hence what is f dash x is always 0. Is always 0. So such things you may have to catch the concept there, so that much time will be saved for us to answer the questions. So this is a constant function. You may have to recollect, and its derivative is surely 0. Like this, there are so many special functions which look special, yes, and in which there is some spark in it. We may have to learn and notice. Then only we'll be able to have the answer immediately. Yes, one more such example. How many functions are there? You look at secant inverse function, sine function, a polynomial ax, and root of x square minus 1. People may think of it in a different way. Secant inverse of, they will be finding, assuming this entire thing to be some x, secant inverse x, 1 by x into square root of x square minus 1, and so on, etc., etc. They will be finding a large step will be obtained at the end. Yes. There is a sin with the problem. What is that? You see, the function, main function appearing at the beginning of the gesture is nothing but secant inverse function. Its derivative secant inverse can be defined. Secant inverse x. What is the domain of secant inverse function? Real numbers minus closed interval minus 1 to 1, isn't it? Or open interval minus 1 to 1, whatever it may be. You see, this is less than 1, sine something is less than 1, secant inverse of a quantity which is less than 1 is meaningless, and we do not find the derivative for those functions which are meaningless. It's not a function at all. So, cannot be discussed with is the right option. Unless you notice that you may waste your valuable time by finding its derivative by taking this to be some x like that, proceed. Very bad of that. So the thing that you have to observe is the function is secant inverse function. Therefore, the number which lies inside that bracket must be less than 1. It should lie between minus 1 and 1. It should not lie between minus 1 and 1. But sine of something is such quantity which is to be prohibited. Therefore, such it is a meaningless one. It cannot be spoken of. It cannot be discussed with at all. That is the right option. Like that, you may have to keep a special eye on the nature of the functions given in the problem. Yes, let me give you one more such function at your glance. Observe this lengthy of function f of x is equal to sine of x plus x square plus root of x cube plus x square plus 1. A lengthier polynomial, mixture of polynomials is given. But you see, the beautiful thing occurring in the definition of the function is integral part of all this into pi. That is the main function. He is asking about f dash x. You need not find this is supposed to be some x and sin x, derivative of sin x is. No, not like that. You don't forget that this is the integral part function or the greatest integrate function. Whatever might be the nature, this is always an integer, right? Why? Because by the basic definition, by the basic structure itself, it is an integer because it is an integral part. You see, it is an integer. Say some n. So it is sin n pi. What is sin n pi? 0. So the function f of x itself becoming 0, isn't it? F of x is n pi. What is f of x is sin n pi, I'm sorry, sin n pi. What is sin n pi? It is 0. F of x itself is becoming 0. What do you say about f dash x? 0. Why? Because f is a constant function which yields 0 at every real number x. Its derivative is also 0. So f dash x is 0. My dear friends, the function looks very brisk and burdensome. But there is some loophole in the definition. You catch hold of that so that you can have the answer directly. So the derivative of this function is 0. Likewise, there are so many functions, so many problems we may be looking at.